Hello everyone, my name is UJ and welcome back to the new CCNA training. So today is the first lecture, so let's get it started. So what exactly the network is? On the left side, think of a network as the road map. So from point A to point B, if you have to travel, you see some of the signs, you follow the rules, there are some intersections, you follow the path, and eventually you cross the line and you reach your destination. So exactly, the network somehow works the same way. So for example, from point A to point B, any file, any packet you guys send, it follows the certain path. It sees where it has to go, and it also follows the signs, which are the rules. So that rule can be provided by multiple devices. So packet knows what exactly the speed it has to follow, what sign it has to follow, and where exactly the destination is. So just like our Google Maps, so you know which is the fastest route, right? So similarly, in today's world, without having any trouble, packet knows where they need to go and what's the most efficient path for them. So that's how the network usually work. And if we have to send any information, packet already knows the destination and everything have its predefined path, so it follows that path and gets to its destination. So what exactly the network is, what are the network used to look like, and how exactly the network is today. So we're going to discuss this first of all to get a basic understanding why we need to have a network. So this is how the traditional network looks like. As you can see, you have couple of devices: laptop, smartphone, printers, scanners, IP phone, servers, and they have different configuration. And you also see a couple of networking devices like switches, routers, and they are connected to internet so they can communicate to each other. This is used to be a traditional network where everything is tied in and you don't see most of the new stuff. So the network has evolved today, and today's network looks like something this. So this is the today's network. So you basically see a couple of end devices at the bottom of the diagram, and they are connected to multiple edge devices. You have data centers, you have servers, you have multiple application servers, and you have different type of functionality for each kind of layer. So everything is changing. So instead of having on premises, things are moving on the cloud. So that is why the new CCNA, it covers most of the new stuff. That's why Cisco changed their guideline, and most of the topics now they cover cloud, automation, most of the new security stuff. So to get to the destination, as I mentioned, there are some rules, there are some path, there are some components which are involved. So let's discuss those network components and network equipment and what exactly their roles are. We're gonna discuss this in today's lecture. So first is client, or you can say PC or workstation. it known with different names. The second component of the network is server. It's basically the same kind of concept as workstation or the PC, but it's more powerful. It has more hardware and resource capacity. So think of it like Netflix server. They have thousands of even petabytes of storage, and they provide services to different clients, which are our TVs, our laptops, our tabs, and our smartphones. The next component is switch. It connects multiple devices together. We'll talk about all those devices in a couple of minutes. So the next component is router. Usually you see the router connecting to the internet service provider. Next component is a firewall. It's a security device. You guys might have seen it in your laptops, PC, Mac, which has inbuilt firewall which secure your devices from any kind of attack or any kind of hack. The first component is the client. According to the definition, workstation or a client is a special computer designed for technical application, and it can be used by one person or multiple persons, and they are connected to local area network. And multiple clients, they have different operating system. Maybe they have Windows. Some of them might have Linux operating system. Some of them would have Mac OS. So depending on what kind of device you use, there are different type of clients. So let's just go over with the type of client we have. You see it in industry and a professional environment. There are different type of clients, workstations. So this is our most commonly used PC, which might have a Windows operating system by Microsoft. Similarly, you guys can see there might be some client or workstation which has Mac operating system. A cell phone can be a client machine as well, and usually it's talking to any of the server to get some information out. For example, as I mentioned in previous example, your cell phone might be getting information from Netflix servers. Similarly, your Mac or PC can get the same information from a server. Next client type is tablet. So your tablet can also request an information from a server. So you guys would see multiple type of client machines or client types depending on what industry you're working on. But you guys can remember a client basically request the information from the server, which is sitting somewhere on the internet, or maybe it's sitting on the local network as well. So let's just talk about what exactly the server is. By definition, server is a computer program or a device which has more resources, and that exactly serves a purpose or sends the information or provides the information to the devices which are called clients. So you guys can see on the left side, the server is providing information to multiple clients depending on their geographical location or how they are connected. The main goal of server is to provide information or response to the request which they get from the clients. One of the most commonly used, commonly known networking component is switch. So the definition of switch is It's a network device or a hardware that connects multiple devices to a network. So it basically connect multiple hardware devices together. They can be a client machine, they can be a server, or they can be any type of IP devices which can have a MAC. So we'll talk about MAC and IP, what kind of devices they are. But for the basic understanding, switch is a device or a hardware that connects multiple devices on a network. So think of it, there's a PC or a client machine. In a very simple way, if we have to connect or we have to transfer data from one client machine to another, usually we can have a storage device like our thumb drive or USB, transfer our data to it, and then just move it to the new machine. But there's another way which is called ad hoc network. So you connect one machine or client machine to another PC or a client machine using an Ethernet cable. So if you have a really small network, this is a network as well. That's called ad hoc network. But what if you have to connect multiple machines or multiple client? You have 4 or 5 client machines. To connect those, it's not feasible to connect all those client machine together using an Ethernet cable. So for that, you connect one machine to the second machine using a switch. And instead of connecting both client machine together, you connect one Ethernet cable to switch and the second Ethernet cable to the switch. Once you connect both client machines together through a switch, so if one client machine has to send an information to second one, they first forward that packet or file to the switch, and switch knows where exactly they need to send it. So you can have multiple client machines, type of client machines connected to one switch, and they start forwarding traffic, and that's how you make a network. So there are different type of switches from Cisco in CCNA because it's a Cisco exam or certification. I'll show you what kind of Cisco switches are most commonly used in your professional environment. So here is just some of example of Cisco switches. Cisco, on the right side you guys can see Cisco Catalyst 2960s, also Cisco Meraki, Cisco Catalyst 9000 series switches, and also Nexus switches from Cisco. So all of them serve the same function, but they have different kind of hardware specs and also the features built into them. So now the next topic is router. By definition, router is a networking device that forwards data packet between computer network. So what exactly it means in real life? Think of it, this is one network, as we guys saw in a previous slide, that you have 2 computers, client machine connected to each other using a switch. But what if you have building A sitting somewhere in US and you have to connect to another building which is somewhere in China? So how exactly you guys connect these 2 buildings? So that's where the router comes in. So building B might be somewhere else, to connect those two buildings or two networks, we need a router. So to forward traffic from building A to building B through internet, they need to be connected via router. So this is how you connect the router. So if you guys can see, building A switch is directly connected to the router, and then router connects to the internet, and building B switch is also connected to the router. So if one client machine from building A sends a file, it goes to the switch of building A, then goes to the router. Through the internet, it reaches the destination router of building B, then it goes to the switch of building B and reaches any of the client machine where it needs to go. So that's the basic functionality of router. It connects two networks together. So if you have multiple building, they need to communicate, they need to send information from one building to another. All of them need to have a router because they are on a different networks. So next is firewall. Just like the previous slide, we have building A and building B connected to each other using routers. But what if we have information which is really sensitive? For example, a credit card information. For example, one person in building A is trying to purchase something online, and he needs to enter credit card information. Is it secure to put that information? What if someone tried to hack that network and get that information? That's the reason we use firewall. So firewall basic functionality is to secure connectivity between two networks. So any traffic, any kind of hacking attack, that can be saved. So that's basically firewall, which have set of rules or policies which can save building A and building B communication without interrupting or without having anyone getting that information. We have multiple types of firewall. Commonly used are Cisco ASA and also Cisco ASA Firepower. As I mentioned in previous slides, most commonly known firewall is computer firewall. So even in your machines, client machine, you might have worked with computer firewall. It's an application firewall, so your laptop or client machine, it's saved, so any traffic going in and out, it's secured. So any kind of attack or hack is saved from a computer firewall. But on large enterprise networks, you need to have a hardware firewall, just like Cisco ASA. And there are new types of firewall, next generation firewall. So the definition of next generation firewall, that's a part of third generation of firewall, which combines the traditional functionality of firewall, and it has more application built into it, just like IPS, IDS. We'll cover that in the security section of CCNA. The basic functionality of firewalls are to monitor traffic, just like we mentioned in previous slide, that if you have credit card information you need to put on internet, it sees that okay, nobody is trying to hack that information, it filter packet so nobody sends any kind of attack or any kind of information depending on the rules. It just only forward or receives the information it needs to be on the network, and also blocks the attack. So but if somebody try to hack into the network, firewall knows it, it saves this network. Today's lecture is endpoint. Endpoint is just like a client machine, but the hardware can be different. If you can see on the left side, it can be a desktop, laptop, or it can be any kind of IoT device like our home automation stuff, thermostat. Maybe it's a smart switch, maybe it's a smart plug or a smart bulb or a ceiling fan, or it can be a lock or a door lock, and also the new smart cars. They are connected to your home network as well. So your wearable devices, all the printer and everything. So end device is the device which is used by an end user like you guys, or like any other customer or any other person. So any end user using these kind of devices is known as endpoints. So today's IoT network, Internet of Things, everything is connected. So the concept is same. They have same networking equipments like switches, routers, firewalls, servers at the back end, and on the front end, on the consumer side, we have all those endpoints connected to each other. So these are the endpoints. So that summarize our first lecture. We'll go into more detail about layer 2 and layer 3 switches, and also about the access points and the controllers. But the overall network fundamentals we have covered. Routers, we have covered switches, the firewall, also the endpoints, the servers, how exactly they are connected. So I hope you guys like this. This is the main part of the CCNA exam. As we move forward with the lecture, we keep on covering most of the stuff. So thank you for watching the video, guys. Please like and subscribe my channel, and also don't forget to hit that bell icon, so every time I upload a video you guys get the notification as well. Once again, thank you guys for watching the video. See you in the next lecture then.